And moving on, thank you, Xabier, for joining in. So you can please share your presentation.
Okay. Now you see my screen?
Yes.
Okay. So thank you very much for inviting us. So I will be talking about innovative tool solutions for crafting solar PV modules beyond mainstream applications. So first of all, we are Mondragon Assembly. We are an international group that is manufacturing equipment to build solar modules from standalone equipment to complete turnkey lines. That's our main activity. In Mondragon Assembly, we have also an automation business for other sectors. In total, we are around 700 people all over the world, more than 100 million euro of sales, with different production plants in Spain, France, Germany, Mexico, Brazil, China, and technical and sales offices in US, Africa, North Africa, and India. And we have more than 40 years experience in automation and more than 25 in solar. So today we'll be talking about the equipment needed on the manufacturing of modules beyond the mainstream. You can see on this graph by ITRPV that the worldwide market share of applications that are beyond power plant and rooftop on 2023, it was around 5%, but the plan is that in 10 years, it will be around 20%. So what today it's seen almost as a niche application, it will be more like a gigawatt scale applications in the future. We see that the mainstream applications nowadays are driven by the euro per watt peak factor, but there are a lot of other applications on BAPV, floating, mobility, agrivoltaics, tiles, etc., where the driver, apart from the euro per watt peak, could be something different like watt peak per kilo, watt peak per something like integrability or beautiness or robustness, some concepts that are not directly on the euro per watt peak concept. So there, what we see is that when someone wants to apply PV on a new application, they normally think on a special feature. So this new application requires a special feature that this feature needs to develop a specific technical solution on the module. So an example, on a BAPV, someone may think that to be able to do a BAPV application, this will require to be a aesthetically pleasant module, and the solution for an aesthetically pleasant module could be to develop a module that has different distance between strings and cells, or to develop a module that has colors or some other solution. But this works in this direction, but the good thing is that it works also in the other direction. It means that someone has developed a module that has a different distance between cells and strings, can create a module that has a feature that has a different shading levels. And this is pretty interesting for agrivoltaic solutions, where the crops being grown under on the greenhouse may need different levels of sun, and playing with the different levels of shading, we can make a specific installation for tomatoes different from something needed for cucumbers. So in this concept, we have this new application that requires special features that develops technical solutions that go then back, and we are able to find something for a new application that has never done before in solar. So all this is regarding the product itself, but all these new PV module with special features need to be manufactured and require specific tools. So the industrial means needed it's important to have equipment to build all this with consistent throughput and quality, and that is where Mondragon Assembly jumps in. So we are building the equipment that is able to do these kind of things. I will go through some examples of applications. where we have been working. So one first example will be a project we did for a company that is doing bespoke BIPV modules, where there is a wide variety of sizes that we're building from 300 millimeters by 300 to 3 meter by 6 meters. So you see from very small to very big sizes, very small batches. This customer was doing unitary batches because every building is completely different, and they needed to really match the size of the module with the project. So we are talking about unitary batch or 3, 4, 5 modules maximum. And then they were playing with a very wide variety of string configurations in the module. So we developed, as you can see in the image, a special travel stringer with features for very long and very short strings, with the possibility to adjust the gaps between cells from 1 millimeter to 150 millimeters. And we were able to build different string geometries within the same module. So one module with a string of 5 cells, and then next to it a string of 10 cells, and then next to it a string of 10 cells with different gap between cells. We also developed the layout that you can see here that was adapted to very small and very large modules, so very adapted to the different glass sizes. The possibility of putting strings in 0, 45, or 90 degrees, so we could really build very different shapes and different designs on modules. And as we were working with very small batches, we were able to also develop order launching software. So all the changeover from one module to another was done in the minimum time with this software. We also developed a specific EL test for such a big module that you can see in this image. So you see here, it's the special application bespoke modules with some specific features that need to be developed on the module, and then the tools that are needed to manufacture these special features. Another example of project, it's a customer that needed to build very light and flexible modules. In that case, it was modules without glass, with tailor encapsulant and backsheet materials, very specific lamination process, and they had no G-box on the module. In that case, compared to a standard mainstream module manufacturing line, as there is no glass, there is no way to carry the modules from one station to another, because it's a flexible and the module will just collapse. So we needed to redesign the complete line with a carrier concept. So we were building the module on top of a carrier, and this changes quite a lot of things on the line. And then for the new for the end of line area, where the edge trimming, testing, and hypot are, and the rest of the testing area is, there the carrier was not longer useful because we were working sunny side down, so the carrier was covering the sun somehow, or the sunny side. So we needed to develop this testing area with robots. So all the module was moved from one station to another with robots instead of conveyors. And also we developed a specific edge trimming system because, as you know, with a standard module with glass, the edge trimming, it's a knife that goes against the glass. And when a glassless module is built, there is no physical reference for the knife. So we needed to develop this kind of CNC-like edge trimming system. So you see, light and flexible modules have special features to be able to be light and flexible, and we needed to develop new technology on the equipment to be able to manufacture that. Another example would be for another customer that is doing lightweight modules but are rigid modules. In this case, they wanted to build these rigid modules for agrivoltaics application, and they were using glassless modules, and the rigidity was coming from a special rigid honeycomb backsheet. And as this is quite a special module, there were quite a lot of specific operations depending on the design of this module that need to be developed. So here, there is no need to have a carrier because we have something rigid to build the module on, but it's on the back. So the complete line needed to be thought and designed and conceptualized with the sunny side up instead of the sunny side down. This means that the stringer, the buzzing, and the laminator were working opposite to the normal orientation in a line. And long story short, we needed to build this laminator upside down. So it was a technical challenge, but we did it. And of course, we developed specific machines because this module has some specific operations like drilling some holes, inserting some elements on this backsheet, etc., that needed to be totally tailor-made for this customer. So a part of these examples, we have also worked in projects where that were related to space applications, where the customers were asking for very odd cell sizes. So we needed to develop or personalize our tower stringer to very small cell size with these technical challenges that were overcome. Then we made other projects, for example, where customer was doing a hybrid PV and thermal module, where on a, let's say, more or less a standard module, a metal plate is added on the back of the module for the thermal part, and there the lamination becomes problematic. So we developed some personalized laminator that was able to handle this kind of process. We have been involved also in some projects related to vehicle integrated photovoltaics, where there the statics is one of the key features, and the use of back contact cells was requested, and there we developed a specific tower stringer for back contact cells. In VIPB also on cars, you see the roofs, they are not flat, so curved modules need to be manufactured. And we did some specific layup upgrades on the layup system to be able to handle this kind of curved strings on a module. So apart from the let's say special applications or things that are out of the mainstream, we also have been working a lot for all those applications that we call the mainstream to be. So we see that there is a lot of development at cell technology level with people working on perovskites, tandem, AJT or TopCon, with new connection modes, with back and front as usual, but also back contact, shingling, and connection technology with welding and ECA. And all these things, before they are becoming mainstream, they need to be developed at laboratory level, and they need to be tested with industrial equipment to see that what is developed at cell level can be something reliable and useful when going to industrial level. So in our approach to this technological support to our customers, we have developed some specific equipment for these lab fab applications. So we have a multi-tool stringer. We call it some kind of a Swiss knife stringer, where we can add and remove different modules, and we could have a tool that is ready for welding, ECA application, front back contact zebra, back contact Maxion, shingling, flat ribbon round wire, and a very wide range of cell sizes, amount of bus bars, etc., in a very flexible and fast change over time. We have also developed a specific laminator for the laboratory needs, where we can have all the membrane and membraneless technology in the same laminator, with multi-step and multi-stack approach, with extra sensorization, so we can put way more sensors and to test the different process on a more laboratory level. And then we can adapt the size of the lamination area totally personalized to the lab level, where normally big laminators are not needed, because the first aim is really to test the industrial process. So as a conclusion, what we see is that there is a huge market on distributed applications, and that this is still growing, and what is now seen as a niche application market will be a gigawatt scale market. On this market, the driving factor will not only be the euro per watt peak, there will be other factors. Standard PV modules will need to be rethought, redesigned, reconceptualized to add some features to be able to adapt to these new applications. And when adding those features, we will be able to see still new applications where until then solar was not needed. And in order to do all that, we will need tools that will be able to do the mainstream, but also tools that are able to do these specific tailor-made applications for the future. And that's all from my side.
Thank you, Javier. That was a very, very insightful presentation. Here's a question from my side. So, how do you see demand for, flexible, non-standard production lines? I'm assuming that these be, more expensive than the traditional lines. So, how much more expensive are these? And how does this affect the production cost for modules, which we all know it's a very sensitive topic today?
Okay, so that's a very good question. Regarding the cost of the line, it's very variable. It really depends on how different the module will be from the standard one, ranging from almost no difference from a standard line from cost point of view to double price, depending on the type of module. The impact of this cost increase on the module line on the cost of the module itself, it's a very, 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 very small, because the cost of a module, it's very linked to the cost of the raw materials. So it's the operational expenditures of the line. So it's the reliability of the line and the yield of the line will be the main factors that will be driving the costs up or down, and not really the capex, the initial investment on the line that will be driving the cost. So it's not a matter of how much the line will cost, is how efficient the line will be on his running, and how expensive or cheap are the materials to be used on the module to be manufactured.
Okay. That's fair enough. Also, one more thing, you just mentioned that, there's a gigawatt market for special modules. So where do you see the most demand coming from?
Okay, so for the moment, we see that this should be a market that is not still on the giga scale, but this will be coming according to the ITRPV chart that I was showing. We see that for the moment, it's more a European trend where this BIPV integration, distributed carports, VIPV also, it's really taking the momentum and will be something more important sooner than later. And we also think that this will be a trend in the US in the near future, but that somehow US is few years behind Europe in the demand of this kind of applications. But this will come also.
Okay. Thank you. Thank you so much for that wonderful presentation and answering our questions. Can I request you to please join the chat room for the rest of the conference? And also one word for all the panelists, please, it will be really nice if you can respond to the questions in the chat addressing everyone and not on direct chat. It will be helpful that everybody gets answers. So yeah, thank you.
Okay, thank you very much.